afternoon. Most of you did quite well. Almost everybody passed, and most people improved their scores even a bit. So, good. It went pretty well. And there's just not enough time today to be returning tests and stuff like that. So, we're missing a couple people. I should do attendance real quick. I'm sorry. I normally don't do this during the podcast, but I kind of need to. Otherwise I'm going to forget. Skyward. What? Yeah, that's my name. Mr. Doom, that's what they call me. If you come in here, you're doomed. So Kyle didn't come to school today. Miranda's gone. Anybody else gone? Kyle, I got Kyle. All right. So what we're doing, we're going to start talking about congruent triangles. And one thing that's really important when we start talking about congruent triangles is the concept of corresponding parts. All right? Let's make this really simple. Everybody raise your left hand. I chose left because I knew you couldn't raise your right. It'd be painful probably. Is it throbbing still? Numb? Oh, well, numb's better than throbbing. Okay. No fun after surgery. So, we all have a corresponding part, don't we? Everyone has a left hand here. Wow. Yes, everyone here does have a left hand. I checked before I did it. How about a right foot? Raise your right foot off the ground. Everyone has a corresponding part. We all have right feet. Now, when we raise our right feet, we're not raising the same foot, but we have the corresponding parts. Their parts correspond to each other. We all have a right foot. They all roughly the same shape and stuff like that. Okay? Maybe a little bit different sizes and stuff. What? Well, and someone else probably has like giant feet, but it's still a foot. It's still got 5 toes and, same basic shape, and, same structure, same bone structure inside. They're corresponding. All right? So corresponding parts is something that is essential. I mean, when there's manufacturing of an assembly line, there are corresponding parts in each different piece, and they all have to be exactly the same, or whatever you're manufacturing won't fit together. I mean, when GM was still running down in Janesville, and they were making the Suburbans, all the seats were pretty much the same size. They had to be, otherwise they wouldn't fit in, right? They wouldn't bolt down properly. They're all corresponding. So the idea of corresponding parts is something that's not just a geometry idea. It's everywhere. It's in anatomy. It's in manufacturing. It's all over the place. In geometry, corresponding parts, again, are parts that are corresponding. They have the same relative position. They're not the same part. They're corresponding parts. So I have 2 triangles here. I have ABC and XYZ. And they have corresponding parts, which means they have parts that are the same measurement here. All right? Congruent corresponding parts. I've specifically labeled them. BC corresponds to ZY. Those 2 are the same length. AC corresponds to YX, and AB corresponds to ZX. They also have corresponding angles. The smallest angles are corresponding. Angle C corresponds to angle Y. Angle B, which connects the green and the black, corresponds to the green and black connector here, angle Z. And angle A corresponds to angle X. Identifying corresponding parts in triangles is going to be really important to what we're doing, because when we're going to show triangles congruent, what we're going to do is we're going to show corresponding parts are congruent. That's how we're going to prove triangles are congruent, by building corresponding parts. And if I can show that enough corresponding parts are congruent, then we'll learn some shortcuts that tell us that the triangles themselves are congruent. All right? That's the idea that we're after here, is identifying and being able to show that corresponding parts of triangles are congruent, because once I do enough of those, then the triangles themselves become congruent. So corresponding parts. That's the key idea that we're working with here. Okay. First thing in identifying corresponding parts is listing them. But we have to also be able to find a way to say that triangles are congruent. So when I make a triangle congruent statement, it has to be in corresponding order. And this is where things start getting a little bit tricky for some people. Here I have triangle ABC and triangle XYZ. If I say triangle ABC is congruent to triangle XYZ, that is not the same thing as saying triangle ABC is congruent to triangle ZYX. Those two are not the same statements because they are in a different order. When naming congruent triangles, order matters. When I say triangle ABC, I can name the first triangle however I want to. The second triangle has to correspond to the first. So if I say triangle A, then to B, then to C, is congruent to this other triangle, what would be the corresponding order? What angle corresponds with angle A over here? X does. And what angle corresponds with angle B? Well, it's between the green and the black side, so which is the corresponding one between green and black? Can you see the green and the black?
Red.
There's red also, but can you see the green and the black? Which angle is connecting the green and the black in the triangle on the right? Can you see the big letter next to it? You can, oh God, David at least he knows his alphabet. Of course, if it was England, we'd have to say Z instead of Z. But it's not England, so we're okay. All right, and so the last angle then is Y. This would be the correct order for the congruent statement, if those are congruent triangles. It's written in corresponding order. So we name congruent triangles. Number one, I have to make sure I use a symbol because we've already named congruent angles. If I use 3 letters, that could be an angle or a triangle, right? So we have to name congruent triangles in corresponding order. Now, that tells us a lot of things about the triangle. The congruent statement itself also works for us. For now, the only way to show 2 polygons are congruent is to show all their corresponding parts are congruent. We'll get shortcuts starting tomorrow. The other consequence, though, is when I know that 2 polygons are congruent, we conclude the statement is in corresponding order. I can tell what the congruent parts are without even seeing the picture. And that's important. That's going to be very useful for us. If I have a triangle congruent statement, like I have right here, triangle MNO congruent to triangle KPJ, I don't know what the triangles look like. I don't know where they are. I just know that they're congruent. 2 imaginary triangles that are the same shape. All right? What does that statement tell me? It tells me actually 6 different things besides the congruent triangle. It tells me that angle M and angle K have to be congruent. It tells me that angle N has to be congruent to what angle? N would correspond to P. It tells me that angle O corresponds to angle J. That's easy. A little tricky are the corresponding sides, but it's there. If we look at it, MO is a side. So segment MO has to be congruent to what segment over here? KJ. I'm sorry, I did MO. So KJ would be correct. MN would have to be congruent to KP, and NO would have to be congruent to, NO would be congruent to somebody? PJ, yeah. So without even seeing the picture, I can tell you what the corresponding parts are. from the congruent statement itself. Which again, working backwards and forwards, this is why it's important the corresponding or the congruent statement is in order. Now, when I ask for a triangle congruent statement, I mean something like triangle MNO is congruent to triangle KPJ. If I ask you to break it up into corresponding parts, that's what I mean. So now if I know the measure of angle M is 72, the measure of angle K must also be 72. We have congruent parts, they must have the same measurement. This is a lot of what we're working on today, is the idea of congruence. Can we conclude that the triangles here are congruent? Yes, we can. Well, how do you know that? Because they got all their corresponding parts congruent, right? The 1, 2, 3 side. Angle 1 is between side 2 and 3 here. Angle 2 is between side 1 and 3. And angle 3 is, yes, all the corresponding parts are in order. How would I name those congruent triangles? Now, a lot of people get hung up here. They go, I don't know how to start. How do I know what the right order is? The fact is, the right order for the first triangle you name is any order you choose. There is no right order when you're naming the first triangle. It can be in any order. I could go A, B, C. I could go B, A, C. I could go C, A, B if I want to spell the word cab, just to be fun. What order would you like to go in for that first one? Somebody make a decision. Cab. Okay. Is congruent to triangle. Now the second one is the one that has to correspond to the first one. First one is any order we want. The second one has to correspond to the first one. So angle C corresponds to angle E, and A corresponds to W, and then Q, B corresponds that way. So that would be a congruent statement for those triangles. And if I'd want to do it a different way, if I decided to do ABC instead, would ABC also be congruent to EWQ? This is important. Would ABC also be congruent to EWQ? No, it wouldn't be. It would be congruent to WQE. Order matters. That's the big message we want to get across today. Corresponding parts in order. That makes a big difference as we name congruent triangles. And a lot of what we're doing today is just talking about naming things in corresponding order. Because, like I said, corresponding parts is it's really the central theme of what we're going to do with congruent shapes today and tomorrow. Now, we aren't always given everything. Sometimes you have to make some conclusions. Notice I have some interesting stuff going on here. I have parallel sides as well as congruent sides. But do I have congruent triangles? Are all the corresponding parts congruent? Well, let's see. Angle A and angle C are congruent. These two sides are congruent. The third side of both triangles is a shared side, isn't it? That's right. So that side's congruent in both triangles, isn't it? Are the corresponding angles congruent? Here's where it gets interesting. What do we have? We have parallel lines. What shape do you see? The Z, which means I have alternate interior angles, right? We're right back to parallel lines and angle pairs, aren't we? That took about 5 minutes to get back there, didn't it? Okay, maybe 10. Which means this angle is congruent to this angle. Okay? Okay. Whoops. So this is congruent. This angle is congruent to this angle. And because these two sides are parallel, I get a Z here too. This angle is congruent to this angle. So triangle ABD is congruent to triangle CDB. To put it in corresponding order. So you can see that this is sometimes pretty easy. Sometimes we're going to have to go back and use facts from parallel lines. It doesn't go away. Geometry is always cumulative. We keep building on what we've learned before. We never just walk away from something we've learned. We just keep using it. So that's kind of the fun of this. Now, just take a look at the assignments, because a lot of you probably haven't looked at the new assignment sheet yet, because I just put it up like 5 minutes ago, or 15 minutes ago. You do have homework tonight. It's not a huge assignment. 3, 5 through 11, and 13 through 21 odd. Yeah. And I think actually we may cut out number 19. Hold on, let me double check that. Page 228. Yep, we gotta do a school, we do homework. Yeah, you can skip number 19. You can skip number 19. Just write it down. I'm not going to right now, I probably don't have time.
Last time I asked if you're going to do that, you did. Will you write it down anyway? Will you change it later, Mr. Dorn?
There, now it's this will be online. So.
Oh yeah, because of the podcast. It's not going to be on.
It'll be on the podcast. All right. Yes. Yeah.